Today we'll be learning how to factor by grouping. So we're going to be looking at 4-term polynomials and factoring out the factors into binomials. So here are the steps you're going to follow. Check for a greatest common factor. So in this step, you're looking for a common factor for all 4 terms in the polynomials, but none of our examples today will have this. Later in this objective, we will have a common factor, so I wanted to list that because it will be the very first step that you need to check for. Step 2 is to split the 4 terms into groups of 2. Step 3, factor out the greatest common factor for each pair. So this will be what you did in yesterday's practice, but you're going to be doing it twice because there'll be 2 pairs. And then you'll factor out the common binomial. So here's your first example. So your first step would be to check for a common factor for all 4 terms, but like I said, none of our examples today will have that. So we go to the second one, which is to split the 4 terms into groups of 2. So if there's a minus sign in the middle there, remember you're splitting it before the minus sign because the negative is attached to the 44. All right, so now we're going to find a common factor for just the first 2 terms and factor that out. So the greatest common factor for these 2 terms is x squared. When we factor that out, what's left is 4x plus 1. And then now we'll do the same thing for the second pair. Now here's a hint. To find the GCF of the second pair, you can always do this trick and get the right answer. So you're going to take this number, negative 11, and divide it by this number, positive 1. So we're going to factor out negative 11. Divide negative 11 by 1, that gives you negative 11. Okay, so we're going to divide by negative 11. So we're going to put that here, and then negative 44x divided by negative 11 is 4x. Negative 11 divided by negative 11 is plus 1. So in this step, this is very important. These binomials should match. And if they don't, you need to go back and check your work. So now we're just going to factor out that the binomial that's inside the parentheses, they should be exactly the same. And then we're going to group the remaining two terms together. And that is our completely factored polynomial. So if you wanted to check your work, you could multiply those together using FOIL or the box method, and you should end up with your original expression. Okay, let's move on to another example. All right, so they don't have a common factor for all four terms, so I'm going to split them into two pairs and factor out the common factor for each pair. So I'm factoring out x squared here. And inside the parentheses will be x plus 7. And remember, I can divide negative 21 by positive 7. That would be negative 3. So that tells me what to factor out from the second set. So I'm going to write that here. What's left inside the parentheses will be x plus 7. Remember, those binomials should match. So then we have x plus 7 and the remaining terms of x squared minus 3. Last example. Okay, split them into pairs. The common factor is x squared. Then we have 3x minus 1. Divide negative 25 by negative 1. That gives us positive 25. So that's what I'll factor out from this side. So remember, we have to put a plus sign here, plus 25 since it's positive. And we end up with 3x minus 1. 3x minus 1 times x squared plus 25. That's what you'll be doing in today's practice.